Good morning, everybody. We're going to start a new chapter today, dealing with not really divisibility, but we're looking at composite functions, our equations, or prime numbers. Is a number made up of other numbers, or is it just itself? And in order to do that, we have to first define what is divisibility. And that's why I gave you the packet. This packet is pretty important. We'll use it in a second. With respect to divisibility, what we're looking at is this question. Is a certain number divisible by another number? Even whole numbers are numbers that are divisible by 2 with a remainder of 0. What does that mean? An even whole number, if it's divisible by 2 with a remainder of 0. Remember, relate this back to what we talked about last chapter. If we had P over Q equals some number K, that's some quotient, then we know that that has to be true. If we multiply both sides by Q, we have this. If it's perfectly divisible, then there's no remainder. So an even whole number, like 8, is it divisible by 2? Yeah. 2 goes into 8 how many times? 4. With any remainders? No. So there's an example of what an even whole number is, what it defines it as. So if that's the case, how would you define an odd whole number? What's that? Yeah. Any number that when divided by 2 has a remainder. But more precisely, so we have 7 divided by 2. How many times does 2 go into 7? With how many? This is what's important. So an odd number, there's an odd number is any number who, when divided by 2, has a remainder of 1. Always. And that's going to become important to us because if we want to find a number that's not an even number or not divisible by 2, all we have to do is find the quotient and add 1 to it, and that number is not divisible by 2. So this plus one will become very important later on. So it's odd if we have this. If we have this, we have P equals QK plus one. This goes right here, where this is zero. So we really have for an even number. Ever seen that symbol before? How about that? How about that? These mean the same thing. For example, now what do you call it? Not nomenclature. Because we use different words to represent different things with this. For example, if we say that 12 is divisible by 2, what does that mean? What's that? No, that's not what it means. Is 12 divisible by 2? What does that mean to you?
That means you can make groups of 2 out of 12.
Right. That means 2 goes into 12, right? Or when we deal with manipulatives, we can make certain number of groups of 2. Or we can make 2 larger groups. 2 is a divisor of 12. Same concept. We're talking about division, but we use a different word. Divisor. What does that mean? Twelve is divisible by 2. We know that. That means that if we take 12 divided by 2, we get 6. We get a whole number. 2 is a divisor of 12. That means that 12, this is really what it means. That 12 is made up of certain numbers. What is 12 made up of?
6.
2 times 6. What else?
3 and 4.
What else?
1 and 12.
Right. We're going to talk about those in a second. But what this is saying is that 2 is a divisor of 12, meaning that it could be factored out into one of its components. These are what we call factors. Twelve is a multiple of 2. What does that mean? What this means is, well, remember we had P over Q equals some number K. That's the division problem. If we multiply both sides by Q, so what this thing says is 12 is a multiple of 2. So 2 times something equals 12. That's what it means. 2 divides 12. That's obvious. This implies that 12 divided by 2 gives us a number with no decimals, with no remainder. And then lastly, which we're going to talk about more so, 2 is a factor of 12. And we talked about division last week, last class and last week, or the week before. When we divide two numbers, so if I had 12 divided by 3, what does that equal? If it's a divisor, if 3 is a divisor of 12, that means it has to equal some unique number. So whenever we talk about divisibility or dividing, the answer has to be unique. In other words, what does that mean? Can you have two answers for the same division problem? No. Can 12 over 3 equal 6? Can it equal anything else other than 4? No. So that's what I'm saying. Is with division, it's got to be unique. It has to be one and only one number. Let's look at the example. Ah, shit. Did I divide that? Ah, that's what I was going to do. So 2 divides 12. How do we put this mathematically? Don't spend your time looking for all this stuff. That's why from now on, I'm going to give you these packets at the end of the class because you spend too much time trying to find out where I am. I'm going to jump around and put things more logical way. This is not mathematical. This is literal. So what we would do here, that's what that symbol there means. 2 divides 12. What does 2 divides 12 means? That means that if we divide 12 by 2, we get an answer. We get a unique answer. That's what this says. This says 2 divides 12 or goes into. Is that true? Since it's not true, we would put it this way. So what this thing says is 5 does not divide 12. So with this, again, whatever's in front, that's your divisor. Your dividend is afterwards. So your divisor is in first, and your dividend is after the bar. Example 1. Classify true or false. True or false? Sure. Yes. Yeah. What this thing says is 3 divides 12. True. True. How about this one? Why not? So how would this look? And anything over 0 is what? Undefined. So this is false. 0 does not divide 2. Zero is even. This is. How do you answer this one? Did we define even anywhere in the lecture today? Yes, we did. That's very. I started off my lecture by talking about defining it as odd and even. That means you weren't listening. A remainder of 0. So, a remainder of 0 if I do what? By. So what is 0 divided by 2? 0. Is there a remainder? Nope. So true. 0 is even. What does that mean? Does 8 divide 12? How about, let me see what it was. No, this is true because it doesn't divide it.
Oh,
How about this one?
True.
True also for the same reason. Remember, this is the bottom number. So does that give us a whole number with no remainder? No. So it's not a divisor. E for all whole numbers, A, 1 over A. Okay, I'm going to ask you why. Why do you say false?
because this was talking about whole numbers, fractions, and considered.
But remember, what is the test? Is it unique? So in our case, we have 1 over A equals K. So so if I look at this, is there a unique number K that when I multiply to A, it equals to 1? True or false? Why?
One can go with,
What if A was 5? Very good. So if for any whole number A, I have 1 over A. So is there a constant number 1 over A if K is equal to 1 over A? What does that equal? A's cancel. So true. Because we defined what K was. A is the whole number, not K. A is the whole number. 1 over a whole number is what K is. So is there a K that when I multiply to any number, it'll equal 1? Yes, they're inverses of each other. So that's a true statement. What these questions are, a lot of these are what you see on like law school and medical school exams. Just how you think through problems. What was that one? F. For all non-zero whole numbers A, we get A squared over A to the 5th. Here, put that right. For all none, yeah. Remember, what is the formula we have to use to test this? To test if this is true, we have to show that there's a value K that makes it true. So in this example, we have A squared over A to the 5th equals K. So is there a number that would work?
To the pound.
Yep. Because A squared times A cubed equals A to the 5th. Because the property is, if you have the same bases, you add the exponents. So that's true. G. 3 goes into 6n for all whole numbers n. What do y'all think? This is elementary school. This is teacher math. Okay, it's true. Why?
Because your base is 6 is divided by 3. So anything times that number for that base would be divisible by 3.
Yeah, so we have 6n equals 3k. So is there anything that we can multiply by? Yeah, k can equal what? 2n. So yes, it's a unique number. Which one are we on? H. True or false? What does it say? How do you read this? 3 is not a divisor of this. What do we know about this number? What do you get? No, what do you notice about these numbers here first? Of what kind of numbers? They're all odd. What do you get when you multiply two odd numbers? 3 times 5 is what? It's odd. 9 times 5, 45. So anytime you multiply odd numbers, you get an odd answer. It's closed under multiplication. So if these are all, when you multiply them, you know it's going to be odd. When you add 1 to it, what does it become? Even. Is an even number divisible by 3? No.
No, nothing.
Oh. I thought you were happy you got the answer right. Right. So this is true because this number here is going to be even, and 3 does not go into an even number. Okay. Here. No, not true. How would you write this? Can you divide by 0? No. So 0 is not a divisor of 0. How many times is 0 going to 0? We don't know. Doesn't go in there once. Because 0 times 0 times 0 is 0. So 3 times, or 10 times, or a million times. So it's false. It's not a divisor. J. For all non-zero whole numbers, A, we get I.
And as long as A is not 0, you can divide it,
So how would you write this?
0 over A.
And does that equal some unique number K?
Nope.
Sure. Very good. That's exactly right. Because any number you put in there times 0 is K, is going to be 0. Very good. See, it's the why that's important, not true or false. That's a guess. If you could tell me why, that's the important part. Very good. Very good. Theorem 4-1. For any whole numbers A and B, if B divides A, and N is any whole number, then This is pretty much what we just talked about. For any whole numbers A and B, if B divides A and N is any whole number, then B divides A times N. Think about that. How would you rewrite this as a math statement? A divided by B. So let's just say 9 divided by 3 is 3. What this one says, no matter what N I put there, as long as A is divided by or divisible by B, then anything times 9 that is divisible by 3. Because the 3 cancels the 9, and we're left with 3n. So it doesn't matter what n is. It's simply a constant multiple. So far, so good. So if B divides A, then B divides A times whatever number we have, any integer. Or no, and I can't say integer, I gotta say whole number. We have a packet of gum with 5 sticks of gum. Is it divisible by 5? If we had a pack of gum had 5 sticks in it, and we had 5 people to give it, can we give out to each one person separately? Yes. So it's divisible by 5. What if we had another pack of gum with 5 sticks? Or let's say 15 sticks in it. Is it divisible by 5? Yeah, because 5 goes into 15 3 times. So what we can say here is if in the first one, and the second one, which since it's a divisible one, we can also say that it's also divisible by 5. We can also say this. Because with these, if 5 goes in A and 5 goes into B. So I know that that's true because A is divisible by 5. A is a divisor of 5. So this is true. If that's true, then I can add my 2 packets. And that means 5 is gonna be divisible inside the sum of those. True. Let's think of it this way. Does 5 go into 15? Does 5 go into 20? So therefore, five has to be able to go to 35. Have we seen this rule before? This is how we add fractions. If you have a common denominator, what do? Add the numerators. And this all goes with this rule here. If it's a divisor, then it works. Theorem 4.2. This is the properties now. Or any whole numbers A and B. Actually, A, B, and D. As long as it's not equal to 0. We have 5 properties here that are going to be true. 1, if D is divisor of A and D is a divisor of B, then D has to be a divisor of A plus B. That's what we just proved. Now there are going to be 4 corollaries to that. If D is a divisor of A and D is not a divisor of B, then what do you think is going to happen here? Not yet. Then we can't do the sum. You can only add the 2 numerators if that denominator is divisor, if it's divisible inside there. In other words, in this example here, we have 10 over 5 plus 13 over 5. Does 5 go into 10? Yes. So what this proved is this. Is 5 going to 13? So even if we added them together, would that be a good answer? No. If D is a divisor of A, D is a divisor of B, and A is larger than or equal to B. Now we have to make this distinction first. Then D is a divisor of A minus B. Why is this so important right here? If B was bigger than A, what would this give us? A negative number. Is a negative number in the whole number system? No. So we have to stay in closure. If D is divisor of A, D is not a divisor of B, and A is strictly greater than B, then D is not a divisor of A minus B. For the same reason we've been saying. And the last one is just if we can switch, because now we've always talked about is D not into B. Well, what if D is not to A? If D is not a divisor of A, but D is a divisor of B, and A is bigger than B, then D is not a divisor of A minus B. Here's an example. Okay, true or false? Where X and Y, these are whole numbers. If 3 is into X and 3 is into Y,
Um,
Is it gonna be X plus Y?
no, but is this one true? And can we expand the rules?
Uh,
that's false. That's why I'm not that.
But is it a true statement though? So in the first one, if we had 3 into, let's say 6, and 3 into 9, does 3 go into 54? Yeah, because what this is saying is, can we take this even further? Instead of addition, what we're saying here is this: X over 3 times Y over 3 is equal to XY over 3 times 3. Since both of these are true, then this one has to be true. Why is it? You guys are correct. It's not what we had in the earlier ones. We had X plus Y. But let's go back. What does X times Y mean? X plus X plus X. How many times? Y times. So multiplication is simply addition. So that's why it works. B. If 3 is a divisor of X plus Y, then 3X and 3Y.
And here's the 50. And so then the creating the first rule, and then,
Is that true? Okay. Does 7 plus 11 equal 18? Actually, that's not what I said. We have to do this. Are those true? Does 3 go into 7? No. Does 3 go into 11? But it goes into 18, so that's false. This is called a contrapositive. If you can find me one example in which it's not true, then the whole thing is false. Yes, it sounds good what you're saying, but that's if you used exact numbers for x and y that are divisible by 3. I started x plus y is 18. 7 plus 11, it doesn't work. You have to be very careful what numbers you choose and which ones you're sticking by. C. If 9 is not divisor of A, then 3 is not a divisor of A. Remember, can you think of an example where that's not true? Why?
Cause 9 can't be divided by 3, to make a whole number, but 3 divided by 3 can make 1.
Yeah, so that's true. But this is true and this is false. Because 3 in other words, what we're looking at is there a number A that 3 is a divisor of, but 9 isn't? You use the perfect one, 3. Does 9 go into 3? No. Does 3 go into 3? Yes. So this is wrong. That's a counterpositive. If D is x plus y plus z, and D x plus y, then what do you think about this one? We have to use the same numbers x, y, and z for all of these, and the same number d. Can you think of an example where that's not true? Before you start spitting out answers, work out your examples first, because I'm going to ask you why. Let's take this example. We have D, the divisor of A, D divisor of B, and A is bigger than B. Then it's true. So let's see if this works here for us. This is A, and this is B. Is A bigger than B? Or equal to? Yes. So because of that, so let's do that. We have X plus Y plus Z minus, this is A, minus X plus Y. This is B. And if we do that, what are we equal to? So we have here, we have X plus Y plus Z. Distribute that. So we have negative X, negative Y. The X's cancel, the Y's cancel, so we're left with Z. Which is what we're looking for. True. Because it has to be the first one, A has to be bigger than or equal to B. The first one has to be bigger than or equal to B. Oh, what time we get out of here?
20.
Oh, right, plenty of time. Unless people are packing up already. Because I can talk forever. Let's look at another example. Now, let's look at, I want to get into these part, the divisibility rules. How do you know if I gave you a number, 117? What numbers go into there? Does 2 go in there? How do we know that? Because the last digit is not even, so it's not 2. Does 3 go in there? Yes, it does. Why? Again, it's a 50-50 shot. It's a yes or no. But why?
Because digits add up to 9. And
If you add up the digits and the sum of those digits is divisible by 3, then this whole number is divisible by 3. That's the reason why. Not simply because of that. It's just because these are divisible by 3, so the whole thing is divisible by 3. Is it divisible by 4? Why not?
not even.
What is the rule for divisibility by 4?
It has to be divisible by 2.
Then that's true. You're not done yet. 4 is made up of what? 2 times 2. So it has to be divisible by 2 twice. To be divisible by 4, you have to be able to divide it by 2, and whatever you get, divide it by 2 again. That's not because it's an odd number. Is it divisible by 5? No, because the last number is not a 0 or a 5. Look at the packet I gave y'all. At the end of section 1, at the end of section 1, I gave you these rules. Divisibility rules for 1 through 13. First off, every number is divisible by 1. True. Now, it's divisible by 2 if the last digit is an even number or 0. It's divisible by 3 if the sum of all the digits is divisible by 3. It's divisible by 4 if the last 2 digits is a number that's divisible by 4. Again, to be divisible by 4, it's got to be divisible by 2 times. To be divisible by 5, the last digit has to be a 5 or a 0. To be divisible by 6, it's got to be divisible by both 2 and 3. So to be divisible by 6, the last number has to be either a 0 or an even number, and the sum of all the digits has to be divisible by 3. So then we know it's divisible by 6. 7 is an anomaly. We'll do that one in a second. 8, if the last 3 digits is divisible by 8. Now, how do we know it's divisible by 8? That's just a big number. But what is 8 made up of? 2 times 2 times 2. So the last 3 digits have to be divisible by 2, then by 2. It's divisible by 9 if the sum of the digits is divisible by 9. All the digits. Divisible by 10 if the last digit is 0. It's divisible by 11 if the sum of the digits in the even spaces minus the sum of the digits in the odd spaces is divisible by 11. In other words, if you have a number like 31257, what this thing says is the digits in the even spaces, so the second space and the fourth, minus, this is the sum, so we have 5 plus 1 is 6, minus the digits in the odd spaces, 7 plus 3 plus 2. Is that divisible by 11? No. So 31257 is not divisible by 11. By 12, it's got to be divisible by 3 and 4. Again, you have to go back. What is divisible by 3? What is divisible by 4? And then by 13, the sum of 4 times the last digit and the remaining digits, repeat the process until you get a 2-digit number divisible by 13. It's a process, which we'll look at as time goes on. But these are the rules that you never even thought about. Why? Because you're used to using calculators. Now, why would this be important? Why would these divisibility rules be important? When would you ever need to know the divisibility? It'll become important in a minute when we start factoring. If I want to know what is the number made up of, we have to know what goes in there. So let's look at example 4. Is it divisible by 2, 4, and 8? And then B is, it's the same numbers. We have 8, 3, 0, 2, 6. So using your sheet, are they both divisible by 2? Why? Yeah, because the last digits are even numbers. So yes, they're both divisible by 2. Is it divisible by 4? What's the rule by 4?
Divided by 2 twice.
Look at the last 2 digits. Is it divisible by 2? Twice. So A is divisible by 2. B is divisible by 2. Is this one divisible by 4? Look at the last 2 digits. Can you divide that by 2? 28 divided by 2 is what? Can you divide 14 by 2? Yes. So this one divisible by 4. How about 26? Is it divisible by 2? 13. Is 13 divisible by 2? No. So that one's not divisible by 4. So I can't divide 26 twice. And 8. The last 3 digits, are they divisible by 8? So 128. Is 128 divisible by 8? In other words, if it's 8 is made up of 2 times 2 times 2. So 128 divided by 2 is what? Yeah, 2 goes into 12 6 times. 2 goes into 8 4. Two times 2. 64 divided by 2. 2 goes into 6 3 times. 2 goes into 4 twice. 2 goes into 3 one time with 1 left over. 2 goes into 12. So yes, this one's divisible by both or all 3. 2, 4, and 8. How about B? Is this number divisible by 8? Well, think about it. 2 times 4 is what? So if it's not divisible by 4, therefore it's not divisible by 8. Because if it's divisible by 8, it's got to be divisible by all the combinations of what 8 equals. Are these numbers divisible by 3 and 9? So what's the rule for dividing by 3 and 9? Okay, which one?
But if they want
Now the question was, what's the rule for dividing by 3? And then what's the rule for 9? Yes, that is for the rule for 3, is add them up and divide, and is the answer divisible by 3? So we have 1 plus 0 plus 0 plus 2. Is that divisible by 3? So yes. So it's divisible by 3. 1 plus 4 plus 2 plus 3 plus 8. 10 plus 4 is 14, 15, 18. Is 18 divisible by 3? Right. So this equals 6. So they're both divisible by 3. Are they divisible by 9? What rule would you use?
Because it has to be divisible by 9.
The sum of the digits. Is 3 divisible by 9? No. Is 18 divided by 9? Right. So for 3 and 9, add up all the numbers. Is the answer divisible by 3? Is it divisible by 3 and 9? Look at your example sheets. Example 7. The store manager has an invoice for 72 calculators. The first and last digits couldn't be read, but we know the rest of the numbers. What are the missing digits? And how can we figure them out? What information does this give us? Why is the number of calculators important? What makes up 72? Times. Right. Since we know these are the numbers that have to be involved in it, those have a direct meaning of what happens there. Let's see about 9. Since 72 calculators has to be divisible by 9, well, how do we figure out this number is divisible by 9? Have to add up. So we have an empty number plus 6 plus 7 plus 9 plus another empty number. Whatever that number is has to be divisible by 9. So what else do we know? Well, we can add up these. 6 plus 7 is 13 plus 9. But we have a problem here. What's the problem? We have 2 unknowns. Are they the same? Not really. They could be the same, they could be different. But what's the rule about divisible by 8? Ah, yes. According to this, the last 3 digits have to be divisible by 8. So the last 3 digits are what? 7, 9, and blank. This number has to be divisible by 8. So how do we figure out what that one's going to be? Because once we find this number, then we can find the last number. So it has to be less than 800. So 8 times 100 is 800. So it's got to be less than 800. Or it has to be less than 100. Eight times 90 is 720. So the numbers we have to look at between those two. Because we're trying to get this number here to equal 79 something. Eight times 95. Eight times 5 is 40. 72 plus 4 is 76. Okay, that could be in there, but that's not 79. So let's try 98 times 8. 72, that makes it 78. So it's got to be bigger than 98. Let's try 99. So the last digit has to be a 2. That's the only number that gives us a solid number. So far, we know our number is this. So now we can add up these numbers. Oh, 7, 7, yes, 7. So it's 13 plus 11 is 24. Whatever this number is has to be divisible by 9. So what does x have to be for a number that's divisible by 9?
3.
We know that 27 divided by 9. So this has to be the first number has to be a 3. So our answer is 367.92. Using what we know so far, we can figure out the rest of the answers. Okay, last example. We have just enough time. Determine, here's a number, 57,729,364,583. Which one of these numbers go into that big number? Okay, first off, let's get rid of the ones we know for sure aren't going to work. Which ones aren't going to work? 10 won't work. Why? Doesn't end with a 0. What about 2? Can 2 go in there? No, because it doesn't end in an even number. What's the rule for 8? See, if you have to look it up, then you didn't think about it. You just spit out a number. I need to know why.
'Cause it doesn't.
5 can't go in there because it doesn't end in a 5 or a 0.
6.
When-
Because it's not divisible by 2.
Yes, for a 6, it has to be divisible by both 2 and 3. Since it can't be divisible by 2, can't be by 6. But for 8, we have a different. Well, that's a good point. The last 2 just ends, it's an odd number, so right, 8 can't go in there. So we narrowed it down to 3 numbers. Is it divisible by 3 and 9? These are pretty easy because what do we have to do first? Add up all the digits. So 5 plus 7 is 12. 9 plus 9 is 18. 13. 16. 30 plus 29. 59. So does 3 go into 59? Does 9 go into 59? No, 11's a whole different animal. What's the rule for 11?
Will be even digits minus the.
Some of the odd digits. And it's divisible by 11. So here we have, here's 1, 3, 5, 7, 9. So the odd digits. Even spaces minus odd spaces, not the digits. So here's odd spaces. So we have 7 plus 2 plus 6 plus 5 plus 3. That's 10, 17, 23. Even spaces. We have 2, 4, 6. Oop, hold on. This is odd. 2, 3, 4. Crikey, I misadded those. Oh, so I see that. So it's 5 plus 7 plus 9 plus 6 plus 5 plus 3. 10, 29, 35. Then we have the even spaces, which are at 7 plus 2 plus 3 plus 4 plus 8. 10, 24. 35 minus 24 is 11. Is 11 divisible by 11? Yes. So that number is divisible by 11. I know your question is, okay, what's that going to buy me in China? No, but this is going to help us in the next part when we start dealing with factoring, breaking down numbers to bigger numbers, from bigger numbers to smaller numbers. What do y'all think? How many of y'all knew any of these rules? You probably did. But no, but I thought a lot of these, I never do half of these myself. But that's what we're done